Hey, good day, good people. Let us look at your centroid. Let's get a bit of understanding. We are dealing with the application of Pascal law. And Pascal law says when a pressure, this would be the definition of Pascal law, when a pressure is exerted on the surface of a liquid, this force is transmitted with the same intensity through the liquid in all directions. This is exactly what Pascal law is saying. When the pressure is being exerted, it will be transmitted with the same intensity throughout. Now, the fact that we are dealing with the application of your Pascal law using the hydraulic press, the small side of this hydraulic press, it is called the plunger side, and the big side, it is called the ramp because it's doing the lifting. Now, on the plunger side, we are doing the pumping. We have the FL. The FL, it is the force from the equipment itself. Now, the FL, it is always affected by efficiency. What is efficiency? Efficiency indicates to us how effective the machine or the equipment is. That is efficiency. Then on the handle of this equipment, the F effort, on the handle of the equipment, that's where the human ability is being applied. That's where you apply your hand and you apply the force then doing the pumping. Now, the F effort, because it is human ability, it is always calculated from 100%. The effort that you apply on that handle, we assume to be at what? At 100%. Now, let us then look at how to calculate the volume on the plunger side. Now, in calculating the volume on the plunger side, before we get to the volume on the plunger side, then we are having the stroke length. The stroke length would be the distance from here to there. This, it is the distance from here to there. Yeah. The stroke length, it is the limiting factor of you pumping, you applying your effort in this system. This distance limits the pumping part of it. Now, in calculating the volume on the plunger, it will be V plunger equals to area of the plunger, area plunger. How do we calculate it? It is pi d squared divided by 4. Right, it will be area plunger multiplied by stroke length. Then the SI unit, it is m cube, because it is meter squared and meter. The length there, it's in meter. Then we get the m cube. Now, if we are given the number of strokes, how many times must I pump? Now, I normally give you the picture of the number of strokes with tap. All right. Let's say you want to fill in the 50-liter container, and you are told that your equipment, it is 100% effective. Per one stroke, boom, one stroke, you get 10 liters. Now, you can tell that you need to pump 5 times to fill in this 50 liters, because per stroke you get 10. It means for me to get 50 liters, I need to pump 5 times. Now, if you are given the number of strokes, it will be V plunger equals to area plunger multiplied by stroke length multiplied by number of strokes, and it doesn't have the SI unit. Then the SI unit for V plunger, it is m cube. Now, the fact that you are doing the pumping on the plunger side, when this on the plunger side, when the plunger is going in and out, you'd realize that there would be a certain fluid that escape the system, and that fluid, it is called the slip. Then in calculating the slip, it will be slip equals to volume plunger minus the actual volume. This, it will be given. Now, if they want you to calculate the slip percentage, it will be V plunger minus actual volume divided by V plunger multiplied by 100%. Right. If they want you to calculate the slip percentage. Right. Then let's go to the rem side. In calculating the volume on the rem, it is V rem equals to area rem multiplied by height. The height would be from there to there if it is two-stage cylinder or three-stage cylinder. How your cylinders extend, that would be the height. Then this would be the limiting factor for your cylinders. But if it's a two-stage, three-stage, then they would double extend. Two-stage, it is the bigger part of this. Then inside there's another cylinder. Then when it retracts, it will be boom. Now first stage, second stage. If there is another cylinder, three stage, then it will be something like this. Three-stage cylinder. But what will extend this? It is that force which is being transmitted with the same intensity. That force which is, then it kicks out that one. Then as you apply the force or the pressure, then boom, it kicks out that one. We call this the three-stage cylinder. Then it will be area rem multiplied by height, then you get the rem. Now the rem as well, right, the rem as well can exert a downward force. Vice versa, it is true, it can exert, the mass of this can exert a downward force. Then you can have the pressure transmitted with the same intensity throughout. Now these are the formulas that we will be working with now another thing that I need to make note of, like I said, that the FL, it's been affected by efficiency, then the F effort, it's been affected, or rather it is calculated from 100%. Now please make note, one of the principles that we studied, or one of the characteristics, is that volume, it is definite. Right, here we are still dealing with liquid. That is why everything has to do with volume and slip. It has to do with liquid. Now this is the characteristic that we learned. You will be equating the two. Then if you are given the areas, then it will be the area plunger multiplied by stroke length multiplied by number of strokes equals to area rem multiplied by height. From here they can ask you to make n the subject of the formula. Then it will be area rem height divided by area plunger stroke length, then you get the number of strokes. Or they can ask you to calculate the height. In calculating the height, it will be height equals to area plunger stroke length number of strokes over area rem. It will depend what is it that they want you to calculate from this given formula there. Right, that's what we have here. This, it has to do with what? With the volume. Right, then let's look at the pressure part of it. Now in calculating the pressure, one of the principles that we've studied, they said pressure does not depend on the volume. That means pressure on the plunger equals to pressure on the volume. Now if that's the case, pressure plunger equals to pressure rem. Now how do we calculate pressure? It is force over area. But on the plunger side, because that's where we are doing the pumping, and you've seen that the FL is on the plunger, it means we are having FL over area plunger equals to, then on the rem side, the fact that this equipment is being lifted, it gives us what? The W. How do we calculate the W? It is mass multiplied by gravitational force. Then this W can exert a downward force, like I've indicated, can exert the downward force, and the pressure would be transmitted with the same intensity throughout. Now the force on the rem side, or pressure equals to W over area rem. This is what we have. Then here we are going to have W over area rem. Then we are going to have W over FL equals to area rem over area plunger. This is the formula that we will be using. Now these formulas, they have to do with the characteristics of pressure in the liquid. The ones that we've dealt with, the formulas, they have to do with what? The characteristics of what? Of liquid. Now on this one, it doesn't mean that if you are given the diameters, then you need to convert them to areas. No, if you are given the diameters, then it will be W FL equals to diameter rem over diameter plunger. Now this as well, it is applicable. Why? How do we calculate area? It is pi d squared over 4. This is for rem. Then it will be area for plunger equals to pi small d squared divided by 4. Pi and the pi will cancel out, 4 and the 4 will cancel out, then you'll be left with the d squares. This, it is d squared, d squared. In short, this formula is W over FL equals to d squared over small d squared. Now, this formula, we will be using it more often. Now, this is the formula that we will be working with to calculate whatever that they want us to calculate. They can ask us to calculate the W, then we need to make the W the subject of the formula, or they can ask us to calculate FL, of which we need to make FL the subject of the formula. Then we have what we call mechanical advantage, like the equipment itself giving us what the mechanical advantage. Now, mechanical advantage, MA equals to FL over F effort. Now, if you are given the MA, mechanical advantage, this is the formula that you will be using to calculate what? The MA. FL over what? Over F effort. All right, this is the formula that you... Now, for us to be able, let's say, to calculate the MA, we first have to calculate the FL. How do we calculate the FL? It is W over FL equals to big D squared over small d, and make FL the subject of the formula, then substitute it in this formula to calculate the MA. Vice versa, it is true they can give you everything that has to do with MA and they would want you to calculate the W. That means you'll first have to calculate the FL in this formula. You calculate the FL, then you take the FL, you use it in that formula to calculate the W or whatsoever. But please make note, please make note that the FL, it is affected by efficiency. Then the F effort, it is calculated from 100%. Right. Now, you are having then here MA equals to FL, efficiency, over F effort, 100%. Now, if they want you to calculate the W from this formula, big D over small d, you must know that the answer that you need to get here, it should be the answer which has been affected by the efficiency. Okay, now for instance, if you are given 80% as your efficiency, then you are given the MA as 12, then you are given the F effort as 300 newtons. Now, in making the FL, it will be MA multiplied by F effort. Now, MA, it is 12 multiplied by 300. When FA, when you multiply that, 12 multiplied by 300, then we get 3,600. Now, this force, it is at 100%. Why? Because F effort, it is 100%. Now, the answer here, it will assume what? 100%. We then have to step it down to this efficiency, since all we are told that our equipment, it is 80% effective. Then it will be multiplied by 80 divided by 100. Then your answer would be multiplied by 80 divided by 100. Then our answer here, it will be 2,880 Newton. Now we have stepped it up down. You can tell that it was 3,800. Then we stepped it out. We stepped it down to 2,880 because we are told that the force FL, it has to be at this value. Then you take this force, then you put it here. You put it here as 2,880 because of this indication. FL being what? Efficiency being what? 80%. Now let's say then you are given the FL. It is 300 newtons. MA, it is 13. Then they want you to calculate the F effort. And you are given the efficiency, it is 80%. Now, when you calculate the F effort, it will be MA equals to FL over F effort. Then our F effort would be FL over MA. Then it will be 300 divided by MA, it is given as 13. Then we get our answer as 300 divide by 13. Then I get my answer is 23,077 Newton. Now this answer, it is at 80% efficiency, because this F effort, it has assumed the 80% here. It has assumed that 80%. Now we then have to step it out to 100%, this answer. Therefore, our F effort would be 23,077 multiplied by 100 divided by what? By 80. Then we would have stepped it up, multiplied by 100 divided by 80. Then our answer, it is 28,846 Newton. You can tell that we have stepped up this answer to 100%. Now this is how you deal with the stepping up and the stepping down and the formulas of your hydraulics, good people. Then I will send a video of the application, but this is what you need to know so far. Thank you, good people.